Bismillahirrahmanirrahim. Welcome back to the NCI video series. In the last video, we learned about how to get all the tools and how to get your computer ready for running the multi-WFN and necessary tools. So in this video, we're going to first have a look at how to generate your files that are ready to be run in multi-WFN. So the first thing is we need either an fcheck or a WFN file to go into the multi-WFN. So if you're using Gaussian, if you run any calculation, like I have run this calculation, the CF3I molecule, um, I have kept the I molecule because it's a heavy element and you need pseudopotentials for that. And there are some kind of tricky things sometimes with the pseudopotentials. That's why I included this example so that you also know in case your molecule has a heavy atom, how will you deal with that? So this molecule is optimized, and you can see that I got a checkpoint file from it as well. So you need to convert this checkpoint file to formatted checkpoint file that is called as fcheck file. And when you have your Gaussian calculation, I hope you know how to run a Gaussian calculation. And there is no special keyword needed for this. You just need your checkpoint file. And then if you open the Gaussian software in utilities, you will find the form check utility. So form check utility basically is to format the checkpoint file. And then you select your checkpoint file, open it, and it will simply do something, and you see that it has produced an fch file. That's called an fcheck file. And if you drag it, you can see that it's opening. It means it's generated correctly. So you have the fcheck file now, which can be fed into the multi-WFN, and then you can do further analysis with it. The second thing is, if you have ORCA software and you have done an optimization with ORCA, you have got various files like you are seeing on the screen. Now you need to convert this .gbw file, which is kind of a checkpoint file in ORCA software. So it has the information for orbitals and everything else. So you have to convert this GBW file into multi-WFN readable format. So there are two options for that. The first option is that you can convert it into a molden input file and then directly feed it into the multi-WFN, which would be easiest at this stage when we have ORCA installed on our system. And if you want to convert it to an fcheck file, I'll also tell you the steps about it later on, so that if you want to get a checkpoint fcheck file that you can open in Gauss view as well, you can do it easily. And at the moment, we'll just focus on converting it into an molden input file so that it can be opened with with multi-WFN. So what I'll do is I'll just copy this one. Where am I? The calculations test. Yeah, I don't need to copy it. So I can just go to this folder. And now if I ls, you can see that I do have this file over here. So let's convert it to a molden input file. So for that, the command is orca underscore 2mkl. So this is the ORCA module that we'll use, and then we give it the name of the GBW file, that is cf316.gbw. And then we'll say dash molden. So I can, make it a bit bolder so you can easily see it. So if you write that command and press enter, it should read the file and, oh, sorry. Yeah, you have to give the file name without the GBW extension because it adds the extension itself, which is kind of crazy, but you have to live with it. So yeah, if you give the name of the file without .gbw extension, because it added the extension itself, and you can see when I added the gbw, it added another .gbw, and then it said, oh, cannot find the file. So now it has made this file .molden.input, which is right here. And we can use this file now to feed into the multi-WFN. And I'll copy this file and move it to multi-WFN folder to have a better idea. So we have all things at one place. So this file is here, and then I also brought the Gaussian fchk file into the same folder, and then we'll do the analysis over here. So now we have both of these files in this folder, and we'll do the analysis on them. So I think I added these files in my repository as well here. So you have the same files when watching the video, and then you can practice the same way as I am telling you, and then yeah, you can reproduce the results, and then you're confident enough that you can move to your own analysis. So you have got these two files in the repository. All right, so now we are done here, and I'll just minimize this and open multiwfn.exe from the folder you downloaded and move to D drive. And now you can simply move this fchk file to here and just press enter. If you are seeing this menu, it means everything worked well. It read the file successfully. So yeah, it tells you the formula, total atoms, molecular weights, etc. Now let's try it. Let's try the molden input file and check if we can read that as well. So you read it here, press enter. And you see a warning, warning, warning. Oh, so many warnings. This is what I wanted to tell you. That's why I chose a file with a heavy atom in it, for which we had the ECP, the effective core potential. If you have such a situation, if you have heavy atoms in ORCA and you convert the molten input file, there is a problem that it doesn't state the charges correctly. So it says that probably ECP is applied. So what we'll do is we'll open this file in Notepad, and we need to convert, we need to change one thing, that is this thing here. So you see that all the other atoms have their valence electrons shown here, and iodine's total electrons are shown. So it has trouble calculating its charge. So we'll just replace the heavy atom with its valence electrons. So iodine has 7 valence electrons. I can see that these are not valence electrons actually. These are the atomic numbers right here. But yeah, that's a problem. It has, I don't know why. But that if you replace it with just the valence electron for the heavy element, let's do it again. So I saved the file. Now if I move it and press enter, you see that that warning is gone, and then you go the formula and everything the same. So now we are ready to do the analysis on this file as well. So yeah, now we got the files ready to analyze, and then the next step is directly the analysis. So yeah, I'll stop this video here and create the next one for telling you how to analyze different things, and how can you um, generate certain kinds of graphs and stuff from multi-WFN using these fchk or molden input files. So thank you very much for watching. Stay tuned for the next video. See you in the next video. Bye.